Okay, so we got here another topic, which is problems dealing with circle and triangle. So let's start for number one. So for number one, oops, I can make it larger. Let's make it, there you go. I think I can make it even larger. There you go. So for this one, we have triangle ABC. Okay, triangle ABC. ABC is a right triangle with right angle at C. Okay, so we got a right angle at C. If BC is equal to 4, so this is 4, and the altitude to the hypotenuse is 1. Okay, so altitude is a straight line from the right angle oh, to here. So if that is a straight line, we can now say that this is a right angle also, right? So find the area of the triangle ABC. Okay, so we are looking for the triangle ABC, and this is also the value of this line is 1, right? The altitude is 1. Altitude is a line from the right angle, straight line from the right angle to the hypotenuse. So if that is a straight line, we can say that this one is a right angle. So let's say that this point is D. So using um, okay, so this is D. Using triangle, okay, using triangle DCB, okay, triangle DCB, we can find, I think we already have a 4 and 1, we can find the angle here. Okay, we can find the angle here. So using that, using triangle DCB, so D is a right angle, that will become, this is tangent, no, this will be the hypotenuse, 4 is the hypotenuse, and this is, what is 1? Adjacent. No, it's opposite, okay? Yeah, this is a, so this will become adjacent over hypotenuse. Is it? No, the theta, this one is opposite, right? Yeah, this is opposite, and then 4 is hypotenuse because it is directly opposite by the right angle. So that is opposite, sorry. This is opposite and this is hypotenuse. So opposite over hypotenuse, that is sine. So sine theta is equal to, opposite is 1 and then hypotenuse is 4. So theta is equal to 14.4775. That's a theta. And then using now the triangle ACB, we already got the value of theta. That will become, let's say this is x. Okay, let's say that is x. Therefore, that will become, you can use this theta. The theta that is, this is opposite and then this is adjacent now. So that is tangent. So tangent theta is equal to x over 4. That is opposite over adjacent. Okay. So x now, so we can have the value of x, which is 4 tangent theta. So theta is 14.4775. So that is 1.0328. So we already have the value of x and we get a value of 4. So all we have to do to solve for a, or for the area, that is just 1/2 base times height. So that is 1/2 times the base is 4 and then the height is the value of x, which is 1.0328. Therefore, the answer is A must be equal to 2.0656, and that will be our answer. So let's go to the next problem. Okay, so let's do number 2. So for number 2, we got a railroad is to be laid off in a circular path. So what should be the radius if the track is to change direction by 30 degrees at a distance of 157.08 meters? So what it actually look like, it is a circular path, right? So you have a circular path, and then let's say that this is the center. Okay, so what you have to know is what should be the radius if the track is to change direction by 30 degrees. So this should be 30 degrees, and then a distance of 157. So this distance, this one is 157.08 meters. Okay, that is the distance of this one. So this is 157.8 meters. Okay. So to get an arc, the formula for an arc of a circle, that is S is equal to R theta, where R, of course, your R is, this R is simply the radius of the circle. So R theta, S is the arc length. So, but remember that this theta should be in radian, So 30 degrees times 180 pi. So this is simply pi over 6. Okay. So to solve for that, S is equal to, this will be your S. Okay. So S is equal to 157.08 is equal to R is the one that we're looking for, and then theta is simply pi over 6. If you solve for R, that will become R is equal to, that is exactly 300 meters. Really easy one, as long as you know the problem. You know the formula. Let's get to the next one. Okay, so let's start our next problem. So we get number 3. For number 3, two chords A and B are AB and BC are drawn in a circle with radius 10 centimeter. Okay. So we got a circle. Okay, so we have to draw here AB and BC. So we get a common point for the two chords. So chords is something, a line that is inside the circle. Okay, so let's say that this is, and then we get another one. Okay. So let's say this is B, this is A, and this is C. Okay, these points. So we get a common point of B. Okay, so this is line AB. So chord AB, and we got a chord BC. Are drawn in a circle with radius 10 centimeters. So we got R equal to 10 centimeter. Find the angle between chords if arc ABC is 20 centimeter long. So this arc is 20 centimeters long. Okay. So we're looking at this, we're required to find this angle. Let's say that this angle is theta. Okay, so in order for us to analyze this, let's say that this is the center. This is the center of the circle. Now if you will make a line here, okay, a line here, and then this angle, let's say that this is beta, no, this is phi, let's say that is phi. We have a relationship with phi and theta. Okay, so in that case we can say that phi is equal to theta. So we got here an S is equal to 20 centimeter and an R which is R equal to 10 centimeter. Okay, so we can use the formula arc length which is S equal to R theta, but our theta now is the phi, right? It's phi. So we got S is equal to R. We can change phi. Okay, let's replace phi with 2 theta. So 2 theta. So we can also rewrite this as 2R theta. Okay, so we get a value for S, right? That is 20. And then 2 times R is equal to 10. And then this is theta. Okay. So that will be divide. Oh, so 1. I think it's 1. Theta is equal to 1. So remember that this one is in radian. Okay, so times it to convert it into degree. So the answer is 180 over pi. So this will be your answer. So that is the angle between the two chords, 180 over pi. Okay, so let's get to the next problem. Okay, so let's proceed to number 4. Okay, so for number 4, we got the area of a small segment of a circle with radius 6 meters is 28 square meters. So find the length of its chord. Okay, so we got another circle. Okay, so we got another circle. And we have a small segment. When you say small segment, this is what it looks like. Okay. There you go. So this one is as a so this area is a small segment. Okay. So let's just let's say that this is ASS. Okay, ASS. That is the area of a small segment that is equal to 28 square meter. Okay, and then we also have R. R is equal to 6 meters. So we are asked to find length of its chord. So the chord is this one. Let's say that this is the center of the circle. So the chord are this one. Okay. Okay. So for the solution of that, so this is R, right? So this is R, and then this is R. And then you got here a theta. That's theta. So to get the solution for this one, we got a formula for ASS, the area for the small segment. Okay. So for the area of the small segment, that is simply 1/2 R squared times theta minus sine theta. Okay. So take note that this theta should be a radian. It should be in rad. So we got so the area of the small segment is 28, right? We got a given for that. So 1/2 R squared, R is equal to 6 squared times theta minus sine theta. You can just use your calcu to get the value, or simply use the function of shift solve. You can do that. So your theta, you should be getting a 2.3 radian. Okay, that's 2.3 radian. Okay, so for that, let's say that this is length. Okay, so we have, so L is the one that we are looking for. So that is the chord. Okay, so that will be the chord. So if you want to find the length of R, I think you can use the formula. No, if I will isolate this one, if I will isolate the triangle, I will isolate that triangle, this is rotate vertical. There you go. Um, if I will isolate a triangle, I can split it into two. Okay. Therefore, this is still R, right? This is still R, but this angle will be theta over 2, right? And then this one, this side is L over 2. Okay. So now we can deal this, or just simply, this is just a right triangle. So the theta, L over 2 is opposite, and then R is hypotenuse. So that will be sine, right? So sine theta over 2 is equal to opposite over hypotenuse. So L over 2R, right? So all you have to do is just find L. So L is just equal to 2R sine theta over 2. So L is equal to 2, R is 6, and then sine, don't forget that the theta or your calcu, you have to make it in radian mode. So 2 over 3, 2.3 over 2. So you should be getting L is equal to 10.95 meters. And that will be our answer. Let's get to the next problem, which is number 5. Okay, so let's continue for number 5. So we have given our two concentric circles. If the chord of the big circle is 10 centimeter and always tangent to the small circle, find the area between the two circles. So it is an annular ring. Okay, so given our two concentric circles, if you see or encounter concentric circles, it means that those two circles have the same centers. Okay, so it looks like something like this. So let's say this is a big circle. Okay, and then we got another circle. There you go. It kind of looks like a donut. Okay, so there is a chord of the big circle and always tangent to the small circle. Of course, obviously this will be our small circle and it is tangent to the so we get a chord of a big circle. Okay, it's not quite straight. And there you go. So this is the chord and it is tangent to the small circle. Always tangent to the small circle. So find the area between the two circles. Okay, so let's say that this is the area. Let's say this is AS and this is AB. Okay, so AS stands for the small circle, area of the small circle, and the AB is the area of the big circle. So if you want to find, let's say this area, which is, let's just call it A. All you have to do, you have to find the area A, right? Area A. So just the it will be the difference of the area of the big circle and the area of the small circle. So all you have to do is A must be equal to area of the big circle minus area of the small circle. Okay? So if you want to get the area of the small circle, that will be pi r, okay, rb, okay, that's the radius of the big circle squared, minus pi and rs, okay, that's the radius of the small circle squared. Okay, so if you want to factor out, we can factor out pi. So you'll have here rb squared minus rs squared. Okay, so we have to find the rb and rs first. So if we have a length here, right? The length of this one is, I think the length of this one is 10, right? Is it 10? Yeah, it's 10 centimeters. The chord is 10 centimeters. Now, if this will be your center, okay, if that will be your center, and I make a line here, let me make that a different color. So there's a line here, and I will also make another line here. As you can see, you will be able to make a triangle, right? So this line here that will serve as your radius of the big circle, right? So this is the radius of the radius of the big circle, and this one will be radius of the small circle. So what is the length of this one? So you can see that will be half of the length of the chord, which is 5 centimeter. Okay, so what you want to find here is, if I will isolate the triangle, it will look something like this. So this is the triangle. So this is 5, okay, and this is r is s, or the radius of the small circle, and the radius of the big circle will be the hypotenuse. And since this is a right triangle, we can have a relationship of the sides, which is the Pythagorean theorem. So for using the Pythagorean theorem, you'll have here 5 squared, no, the hypotenuse first, so rb squared equal to the sum of the two squares of the sides, so 5 squared plus rs squared, right? And then if I will transpose rs squared, you'll have here rb squared minus rs squared equal to 5 squared, which is also equal to 25. So as you can see, rb squared minus rs squared, that is also this one. Okay, so all you have to do is just substitute the value. So a is equal to pi, and this one will be 25. Therefore, the answer is just 25 pi. Is it in meters? No, it's centimeter. Okay, so centimeter squared. So this will be the answer. Okay, so let's do the last problem for this one. Okay, so we got number 6. So for problem number 6, we got the first one. So this is letter A, and then this is letter B. I already drew it ahead of time. So given is a triangle with size 8, 10, and 12 centimeter. Find the radius of the circle that circumscribe the triangle. So when you say circumscribe the triangle, it's like the circle is hugging the triangle. Okay, it's like hugging the triangle. So it should be the circle should be outside, and the triangle should be inside. And then the other one for letter B is inscribe in the triangle. So if you see encounter this term inscribe, it just means that it must be inside. Okay, so the circle must be inside the triangle. So as you can see, for number 1, the triangle is inside the circle, and for letter B, the circle is inside the triangle. Okay, so with that, so we got here 8. I won't write the units anymore. So we have 10 and then 12. Okay, so for that, if you see, if the triangle is inside the circle, the formula will be, okay, area of the triangle is just equal to ABC over 4R. Okay, what we are looking for is the radius. Okay, radius. But first we have to get the area of the triangle. So for the area of the triangle, we can use the Heron's formula, or the Hero's formula. You can use that formula if given 3 sides. Okay, so that will become, the formula for that is S times S minus A times S minus B times S minus C. So ABC are the sides of the triangle, while S is also called, that is A plus B, no, A plus B plus C, but it should be over 2. So this one is called the semi-perimeter. Semi-perimeter. Okay, so let's try to get S first. So getting S, you'll have 8 plus 10 plus 2. right? So that will be 20. 20 over 2, so that is 10. Is it 20? No, no, no. This is 12, sorry. So 12 plus 8, that's 20. So plus 10, that's 30. So this must be 15, no? 15 centimeter. So that is S. So let's try to get A. Okay? The area of the triangle now will be equal to square root of S. Okay, so that is 15 times 15 minus 8 times 15 minus 10, and then 15 minus 12. And then the value for that will be equal to 15 square root of 7. Okay? Therefore, to get that, to get the value, so we have area of the triangle is equal to ABC over 4R. So area of the triangle is 15 square root of 7, square root 7, and then ABC. So this is 8, 10, 12. 8 times 10 times 12 all over 4 times R. So if you get the value of R from that equation, you'll get R is equal to 6.0474 centimeters. Okay. So this will be the answer for letter A. Okay, so let's try now letter B. Actually, let's I will move this drawing to here. Okay, I think that's fine. So we still get the same triangle. So we can say that this is, okay, so we can say that this is 8, 20, 10, and then 12. So if the circle is inside the triangle, this is much simpler. The formula will be the area of the triangle is just equal to RS. Okay. So the area of the triangle, we were able to compute that already. So that is 15 square root of 7. So that is 15 square root of 7 equal to R, which is the radius of the circle. And then S is also the semi-perimeter. So 15. So R will just simply be, you can cancel out 15, so R will just be square root of 7. Or this is also equal to 2.6458 centimeter. Okay, so that will be the answer. And with that, I think we're done with this topic. Let's move on to the next one.